Hello, everybody. This is Christopher Mick with Space St. Croix. I'm very excited today. We have a special guest that I will introduce here in a second. But this is kind of for our Girl Scout groups that we don't usually, or we do usually do an on-site program for. And I feel really bad with the COVID restrictions. We haven't been able to do those. And so I've been racking my brain trying to find ways to get cool programs to you since I can't be there in person to share some stuff. So I have a special guest. I'm going to get right to her and we're going to answer some of your questions and hopefully have a fun time on this short little STEM-based video. So I will throw it over to you, Athena, if you'd like to introduce yourself.
Yeah, hello everyone. My name is Athena Brensberger. So I'm actually a science communicator that specializes in astrophysics. And what that just means is I went to school for astronomy, pursued research, went into studying the stars and understanding the cosmos. But I decided to really pursue more of a path of actually communicating that. So this has to do with making content or going to museums or like speaking with you guys about why this stuff is important. And I think why more people should actually pursue it as a career.
Excellent, excellent. Well, and I'm going to get right into it because one of the reasons I was excited to speak to you, and I've full disclosure, follow you on social media, and I've seen some of your amazing trips and experiments that you do for people on your channel, is that in doing some of the workshops and things I've done in the past, I've kind of bumped up against the preconception that kids have sometimes on what a scientist looks like, or what an astronaut looks like, what an engineer looks like. And we've done some of those exercises that I know other educators have done, where it's like, draw me a picture of what you think an engineer looks like, you know, what they wear, how they look. And you'll see a lot of the pictures are of a white male, unfortunately. And that's kind of the stereotype, or maybe that's just kind of the image that's stuck from the Apollo program or earlier in space exploration. And those are kind of the images that are handed down. And I like breaking all that open because I like introducing the kids to that there's all these people they may not have known about that do science communication work, that do nutritionists, that are biologists, that are researchers, that have gone on to become astronauts. I like showing the latest astronaut class photos compared to the original ones where it's like 50-50 men and women now.
Yeah.
Versus the original astronauts where it was all that kind of white, you know, male test pilot military background. And so I just wanted, if you could talk a little bit about just your experience with schooling and where you are now and the people you've met and worked with and how it's kind of impacted you.
Yeah, well, definitely the people I've worked with and have met over this journey have impacted me so tremendously. And it just starts from really the inspiration of whether it's, you know, this is maybe at some of your guys' first time of hearing about astronomy or astrophysics, or if, say, like one of your friends gives you a book. And actually that was how it really started for me. Was I was 12 years old, so in 7th grade, which some of you may be 12. And I got a book of images taken by the Hubble Space Telescope. And back then I actually thought they were paintings. And I thought they were kind of like this artist rendition created by an artist, a painter, whether it's graphic designer or acrylic paint. And I realized, like I was told, I learned that day, that these were actually real images of things called galaxies, where there's billions of stars and probably also planets. And to me at 12 years old, I just thought, wow, okay, so there's probably more life out there. And this is going to be my mission for the rest of my life, is to actually pursue this industry. And so that definitely made a huge impact on me at such a young age. And at the same time, I've also pursued art. Like I was a dancer for 15 years, did competitive ballet, but also fell in love with theater and music. And I think that a lot of times there's this misconception that you have to choose one or the other, when that's actually not the case at all. It never really was. And so what you brought up about, you know, kind of the stereotypical view of what maybe a scientist, an engineer is, really it's a human being that has that skill set. And I think that it's beautiful that we're starting to see so much more of that. As you mentioned, the Artemis program is 50% women, 50% men. And that's actually brilliant because that's a true representation of humanity. So yeah, so that's a little bit of my spiel,
That's
my
good.
inspiration. Yeah.
Well, and that ties into one of the first questions we got from one of the Girl Scouts was, where did you go to school?
Yeah, so actually I'm a New Yorker, native New Yorker, born and raised. And I went to the College of Staten Island. So I was originally a Brooklynite. So anyone knows what Staten Island is, it's kind of like a separate island, part of New York City. It's a borough. Um, but it's really just kind of surrounded by a body of water. So you have to get to it by ferry. But it was the only city university, part of the city university program that had an observatory on campus, massive observatory. And so I went to school there. That's where I ended up pursuing my research. I met my professor who became my mentor, Dr. Charles Liu, who actually still speak to. We just had a Zoom call the other day. And that's where I started doing my research, was there. And then I continued it at the Hayden Planetarium, where Neil deGrasse Tyson is the director of. And that's where I ended up really kind of delving more into what my mission is as an astronomer.
Okay, excellent. Well, and then that kind of segues into my next question I've gotten from one of the young ladies was, do you have a favorite science experiment that you either do with students or you've shared? Because I know you've done a lot. Following your social media, you've done a lot of great demonstrations and kind of how to and do it yourself experiment.
Yeah, I love DIY experiments. I think those are some of my favorite, because it just really, I think, conveys so well to anyone of any age group. So I think my favorite one would probably be, I do like the DIY general relativity, which essentially shows Einstein's theory of how space-time will warp due to the gravitational effect of an object. And so depending on the mass of that object, it'll bend literally things around it, the interstellar medium. So whether it's gas or other particles, dark matter, nearby planets. And so you could do the experiment by using like, say, a pair of leggings or a t-shirt, and you stretch it out. And then you can use different objects like a headphone case here, a marker, and watch how it bends the fabric. And this is a good way to sort of show the gravitational effect, which is that bending, the warping, based on that body of mass. And this was, you know, Einstein's theory of general relativity, which later branched into the understanding of black holes, and maybe potentially one day wormholes, discovering them, hopefully, fingers crossed, because we still haven't really discovered a wormhole, but mathematically they've been predicted.
Yeah, I get excited, and I could see the kids kind of light up. I did a program last year when we were still doing in-person programs on exoplanets, and that was blowing a lot of the kids away. And I had some of the art. I got one of them here, the artist renderings of what an exoplanet might look like if you were standing on the surface looking at its star, and pretty amazing. The kids were like, wait a minute, there's planets and moons around it. I'm like, oh yeah, and that's why we get into like what you're talking about on, if you can find those planets that are in a habitable zone of their star, then you can get into that, could their life be happening on that planet? And the kids are blown away. I found, at least, when you kind of show them the different makeups we found, where they kind of think everything looks probably like our solar system does. And I'm like, no, you got some where the gas giants are right next to their star and they're huge, and those are the inner planets. And then you've got all these crazy things happening. It's not like everybody gets a solar system like we do, where you have the small rockier planets, on the inner planets, and then the gas giants on the outside. So it's interesting when that just fires off a whole lot of questions, because they're like, wait a minute, could there be liquid? I'm like, well, yeah, if it's in the right, zone, there could be liquid on the surface and stuff. But it just gets all these great questions going, and you can see how excited they get, and that they had no idea that was going on, because maybe that's not making the top of, the news or the things that they're getting exposed to. And they had no idea that there's, been thousands of exoplanets discovered around other stars.
And I think those curious questions are what's so beautiful about speaking with the youth, with younger generations, because I think a lot of times, as we move into adulthood, we tend to not ask as many of those questions. Those big, well, why questions. And that's what's so brilliant, I think, and I love so much about astronomy, is it's such a humbling science, first of all, but it's also that one science that is really evolving so frequently that you actually have to really be okay with the scientific method of saying, well, this theory no longer stands because it's been disproven. I have to let go of that, rather than holding on to that. Well, I've always believed this my whole life, I have to stick with it. And I think coming to terms with that is so important in other aspects of life, whether it's politics and government and economics. All of that, if we all applied the scientific method, I think that our world would probably be a bit different. I think it's quite interesting, even just the way that humans interact with each other as well. So that's why I'm a huge fan of astronomy too, by the way, is what you
Oh
just
no, well, I
mentioned.
mean, yeah, I'm preaching to the
Questions.
choir. I know we're both geeking on
Yeah.
the same stuff, but that's I for a group of older kids, I did a session where we go all the way back to like Galileo. And like you're saying,
Yeah.
following the science, that it's just the science. And when observations were made that, okay, the Earth isn't actually the center of the universe, we're going
Hmm.
around the sun. And again, it wasn't to be a religious confrontation or political thing. It was just like,
Yeah.
this is my data. I'm
Yeah.
drawing, I'm observing, I can, show you the math, I could show you, and
Yep.
that was all that was driving these people. And they would go under house arrest, or it would be but
Mm.
that was the data. They weren't trying to make waves or cause a problem. They were going wherever the data took them. And I like that. And
Yep.
I illustrate that still happens even today, as you're kind of hinting at with things on the origins of our moon, on
Hmm.
collisions with our Earth, on a Mars-sized object, and that they keep
The shape
refining
of
the
our
data.
Earth.
Yeah, and they run the computer models, and you're like, the data is actually indicating, something probably like this happened, and that's a new
Hmm.
theory that we didn't have 20 years ago. And I'm like, to your point, I try to stress that they're just following, the data, and that wherever it says, maybe it took a totally different direction than they thought, but they're gonna go where the data's, taking them. And I think that's kind of a
Yeah.
beautiful thing, where you're just crunching numbers and trying to get more and more data, and that's going to make you, and it's never a certainty. I always stress that too,
Hmm.
that it's like our best educated guess at the time, or this is what the data says. But if something contradicts that, we're going to go with where that new data takes us. So
Yeah, exactly. Yep,
to your point,
definitely.
I agree with that. And then I got one question right before we
Yeah.
went on the air, and I was searching around to grab my model, because I had one Girl Scout ask, have you ever gone to a rocket launch? And I know you've gone to a lot, but I have a model that I know you will recognize here.
Yes, Ariane
So
5. That is
yes,
incredible. Yep.
because you did such a great job covering that and posting about that leading up to the
Thanks.
launch, and you got such great access for all that. So I don't know, you can talk about any rocket launch you want. I know you've been to more than one, but I thought, oh, I got to grab my model to share, because I'm like, I know you went to that one for sure. So
Yeah, I mean, you have so many rocket launches. I mean,
yeah,
rockets behind you as well,
yeah,
rocket models. That's
yeah,
incredible. And I see the ISS. Oh, that's
yeah.
amazing. Well, yeah, I'll start with, I guess, the Ariane 5 rocket you just held up, which is part of Ariane Group and Ariane Space. I'm trying to do the accent. I can't do it
Yes,
well. French Space Agency, part
yeah,
of ESA, the European Space Agency. And they've been launching rockets for over 40 years. And that launch specifically, I got to go to. We created a show, an online show on Facebook, to actually cover these launches and bring on artists and bring on musicians and bring on scientists, of course, and researchers, to actually talk about this launch and talk about like Mars or going to the moon. And what was so exciting about it was I got the opportunity to actually go to French Guiana, which is right by the, like, in the Amazon jungle in South America, and cover this rocket launch. And it went like right overhead, which was just incredible. And for me, it's, you like can feel the rumbling of the engines. And I think that that's probably the most exciting thing for me, is really the audio and that physical like effect you get from an actual launch. So that's a really exciting one. But something to actually let any viewers of seeing this video to know about is whoever is 18 years old or more, or will reach 18, is a program that NASA has called NASA Socials. And I think you have to be 18 to apply. And so it's incredible. I don't know if you've gotten to go
yeah,
at all. You
yeah.
have? Okay.
I did a James Webb Telescope one at Greenbow. They finished installing the last mirror, and they flew us out for
Wow.
that. So that was awesome. Yeah,
Oh, that's incredible. Yeah,
yeah.
I mean, it's such an extraordinary program that really started as Twitter, NASA tweet ups,
Mm-hmm.
um, for people to just come and go inside the NASA facility, talk to researchers, talk to engineers, and get to even maybe even see a rocket launch or see something like special like you did, seeing the last mirror being placed on the next, monumental space telescope. And I think that these experiences are so awesome. And so NASA really opened their doors to a lot of people that can apply to go. And you don't have to have a huge social media following. Like, you don't have to be in science, but I think that to find it interesting and to want to share it on your platform is what they're really looking for, is to sort of share with the world what NASA's doing and why this stuff is important. So yeah, I got to go to a bunch of launches for that. I went to a SpaceX launch and seeing the boosters landing on the Falcon 9 rocket. I mean, I don't know if you've ever gotten to see that. The first stage booster land is just extraordinary. I didn't get to like actually be close to see it. Some people go out into the water to see a SpaceX. So what I mean for anyone who's watching doesn't know what the booster is, that's the first stage separation. When it burns through the fuel for the satellite, it separates, stage separation. The satellite then heads over to space, and then that booster has enough fuel to then land, so it can be reused, similar to getting on an airplane and getting off an airplane, other people get on the plane.
Yep.
What's so exciting about it is the first time this ever happened was through SpaceX. And so to see, and this was only, I think in 2015 was the first landing of a booster. And so it's really an extraordinary thing to see. And you hear like the sonic boom happen as well, like right when the engines reignite. And it's so awesome. Have you gotten to see one?
Yeah, in Florida, I got to see a SpaceX, and like I was just going
Wow.
to say, when you mentioned it, that sonic boom is pretty intense. So that's, coming back in, because you can see, if you're looking right and it's clear, you can see the engine relights.
Mhm.
There's that reentry burn, and then there's the landing burn, and you can, on a clear day, you can actually see those too, which is pretty
Yeah.
amazing. But then, that sonic boom when it's coming back in. To your earlier point on the noise, that's the really hard thing to convey in the videos, unless
Mhm.
you're there, just where you're actually feeling it, against your chest, and you're kind of feeling that
Yeah.
sonic boom crack all around you. That's kind of hard to convey in just photos or videos, but
Yeah.
it's,
Yeah, definitely. I have
it's
some
pretty amazing.
friends, I don't know if maybe you should totally interview them as well. The Cosmic Perspective, Ryan and Mary Liz Bender.
Yeah.
Yeah. So, okay. Yeah. Mary
And
Liz has
they
been doing an
post some amazing
extraordinary job with
audio.
it.
Yeah, the
Yes.
audio they
Yeah.
put, well, I put my headphones on, and you get that oral
Feel like
surround.
you're
Yeah.
there.
And I'm like, that's
Yeah.
amazing. Because
She's
that
built this
track.
like cone thing with the microphone inside and like a little tunnel around it to
Yeah.
create that absorb the sound really well.
Yeah. Well, and that's
Yeah.
another point I was going to touch on. You're kind of hitting it there too, is that um, it's been challenging, obviously, in COVID-19 with everything going on. But in talking to some other people, I was actually saying it's really rough, and I know a lot of people are hurting, and a lot of people want to get back to normal routines. I said, in an odd way, it's probably been my best year for connecting with people like you, and attending online presentations and conferences. I went to the Humans to Mars conference, and I said, I've done more cool presentations, webinars, conferences, Sci Com people, interviews, stuff I never would have done before, honestly, because if this hadn't happened, I probably wouldn't be talking to you now, or the other amazing interviews I've gotten to do over the last year. So I said, that's been really wonderful to kind of network and preach science and spread the love about exploration, or if it's a night sky, or observe the moon night, or whatever's going on. A lot more people are, I'm seeing reports on telescope sales going through the roof. More people are buying
Yeah.
telescopes because they have the free time. So I said, I know there's a lot of bad stuff. I'm just really thankful for that good stuff like this that seems to have
Mhm.
come out of that. Can you speak to any
Yeah.
about the past year for you? I know you've done some informal teaching and different things like that.
Yeah, definitely. It's actually funny you just brought that up because yeah, I had just begun formal teaching now, just an
Okay.
hour before this, at Dexter School, which is a private school out in Texas based, really around science and STEM education. And I just began my formal astronomy class now teaching there, which has been really exciting. But yeah, what you were saying is this time period, right when it started happening in March, I had a couple of interviews, and I remember people asking like, how do you feel, like what's like that important perspective to share with everyone right now? And it was kind of based around like the overview effect, the cosmic perspective, which is like when an astronaut is, you know, it can experience cabin fever, they're in a small contained environment, but then looking out the window and seeing Earth, and how that can almost bring a bit of serenity during these tough times. But during those interviews, I remember saying, these are the times that true innovation can really start to evolve. We can start to see it blossoming, because now with everyone being in quarantine, yes, there is a lot of boredom happening. I've seen all over social media people saying like, oh, like I'm bored, I should do a FaceTime happy hour. But instead, really, really like, lean into those moments of quiet with yourself and start to innovate. think, okay, what can I actually create in this downtime? What can I really start to develop? What skill sets can I work on? And I think some people really, really took that on. I think some people really actually like moved forward with that. And that's why we're seeing, like you were saying, is um, a bigger increase in like virtual events, people actually coming together in community, more podcasts coming out, more like information being spread in a positive realm as far as like scientific realm goes. And maybe other forms of communication as well, other types of industries, business, marketing, etc. And so I think that's a really important thing to take notice right now that's been happening. I mean, even schools, like I know there's so many schools that are truly struggling, like a lot of public school systems, because of the old structure and the old format was not prepared for something like this. And so now they're almost being pressured and forced into now developing a new format, a new way of teaching the students and working with them. And looking at how YouTube has become such a big platform for science educators, PBS, National Geographic, History Channel, a lot of, I think, educators and teachers are starting to now sort of almost like kind of develop in that method now, follow in that way, follow those footsteps of kind of what these platforms are doing, but now kind of create their own. Don't just rely on YouTube. Let's make our own YouTube for our own educational system. And I think that that's something really extraordinary. And that's actually what I love so much about the school that I'm teaching at, because they've literally done just that. And at COVID's what's helped like kind of catapult that. And so this is something that I really think is, can be widely beneficial, I think, if we start to really build up the tools for it. And I hope to see more people really innovating things that we could use in our modern day.
Yeah. Well, and this is going to kind of segue into my last question I had from the Girl Scouts here was, and I'm going to read it so I get it exactly right. How do you research the stars? They want to know how we research stars.
Such a good question. I've got my whiteboard.
Excellent.
I could definitely draw that out if you guys would like, but pretty much how I researched it, my research was on proplyds, protoplanetary disks. So I kind of just like the name proplyd, because it's a short little acronym, but it sounds cute. Proplyd, protoplanetary disk. And essentially there's a giant cloud of interstellar gas and dust, literally gas and dust. And in some regions, it might be a little bit more lumpy here, but there might be more dust, more gas that's over here, and it could actually collapse under its own gravitational effect, and a star could form. A little example I like to use is if you have dust around your house, and maybe the dust will start to accumulate in one little area, and a dust bunny will then form. It's kind of like what's happening with stars that are forming in a dust cloud, an interstellar dust cloud. But what's special about this is this dust cloud has all the elements that are necessary for new stars to form. And what's even more interesting is how this dust cloud even formed was actually from a star that died. A star literally died and released all of its elements that is necessary to create new star life. So what I was doing to research and study the stars was to look at these baby stars that are forming, and right around them is a disk of all of that dust and gas nearby that's orbiting around it. And this is a proplyd. This is essentially the early stage. Yes. Oh, I love it. That's amazing. Is this the Orion Nebula?
This is a Hubble image. This is the, oh, I can't read now. Giant Red Nebula, NGC 2014.
Okay, nice.
This was the special Hubble 30th anniversary image, but you're making me think of what you're drawing. I'm like, I got a cloud image there, yeah.
That's perfect. Yeah, that's a perfect representation. And so you could see these brighter regions. There's stars that are forming everywhere. It's actually called a stellar nursery. And that's because literally like a baby's nursery, but where there's babies, but they're baby stars. And sometimes around them, because they're spinning really fast, they attract nearby dust and gas, and it forms a disk. And eventually that disk can form into planets like our own solar system. And so my research was to figure out how long it might be able to last for the planets to eventually form by measuring how much of this dust and gas is actually being lost, because it's shaped like a teardrop due to wind. Just like how wind is blowing sand on a beach, there's wind coming from a nearby star. There's a lot of stars, they're not alone. There's other stars, and they produce stellar wind and stellar radiation. I know it's just kind of a lot of squiggles here,
Yeah.
but essentially it's producing a lot of winds, a lot of radiation that can actually blow apart the disk before planets form. So my research was to figure out how much of the mass is being lost, so maybe it can survive for planets to form. So that's how I studied the stars. My whole thing was to eventually try to find life beyond Earth. So that was it in a nutshell.
Oh, that was awesome. I think that is a perfect place to wrap up. So yeah, and I just was going to share some of the things that, where am I putting everything that I'm going to try to
Is
put.
that Sally Ride?
Yeah. And I've got
Wow.
Catherine Johnson's back over there. I didn't want to pull her out because I'll knock over my launch tower. But yeah, I bring these ladies with when I do an on-site program to talk about some people they may not be familiar with and kind of their story. And then we're just going to share these are some of the, guides the ladies use when they're earning their STEM badge and things like that. So
that's great.
I'll be sending these in kind of banker's box kits to the ladies in advance since I can't be there, and they'll get distributed those things. And then we'll be doing other videos like this. But I can't thank you enough for taking time out of your schedule with everything for speaking with us today. And I am going to share everybody with your social media links and all that so they can follow you after this interview and see your other rocket launches and teaching and science experiments and DIY stuff that you're doing. So it's just been amazing what you've been sharing. I'm very thankful that we're connected on social media for that. It's been a lot of fun to follow along your journey with STEM education, being a science communicator, and your clothing line. We didn't even talk about that, so they can.
Oh yeah, I just launched that, coming out with a new one very soon, collection 2. I'm excited. But thank you for having me. This has been so incredible. I'm super happy, and I'm also really glad we're connected on social media too. Such a good platform for connecting with others in the science community if used correctly.
Yes. So we'll wrap it up right now, and tell all the Girl Scouts, I hope we can see you again next year for in-person programs, but we'll be sharing this video and, like I said, sending some physical resources your way. So until next time, take care. Thank you.
Bye. Thank you.